Good afternoon, ladies and gentlemen. My name is Thabiso Magwaza, and I am extremely traumatized. The reason I'm traumatized today is not because I'm speaking here in front of you. That's still a bit traumatizing, but I'm more traumatized by something that happened to me a few months ago. I was on a flight from Johannesburg to Cape Town, and it was meant to be a routine flight. Nothing bad is supposed to happen until we got an announcement from the pilot about 10 minutes into the flight. He told us that something was wrong with the airplane and we needed to make an emergency landing. So, I mean, he was calm about it, and everybody else seemed calm. But I've watched enough air crash investigation to know that whenever anything's wrong with an airplane, the only thing that's going to happen is this. So at that time, I was just contemplating my future and accepting my death. I decided to sleep. I knew that one of two things was going to happen. It was either I'm going to wake up in the airport or I'm going to wake up in heaven. I was fine with either. Luckily, I did wake up in the airport, as you can see me standing here today. But the whole experience did leave an impression on me. It made me think about why was I on the airplane in the first place? I mean, I can understand cars, right? A car is something that works. I can see the driver actually driving the car. I can see the wheels moving and I can see it turning. But with an airplane, it just seems so unintuitive. Like, why do I expect this big bus to actually fly in the air and stay there and land safely? Thought a lot about that after that day. I thought about how stupid I'd be trying to explain this in heaven, that I got on a bus and it was supposed to fly me somewhere. So I started to think about uh, the physics of it. I was like, okay, maybe there's some physics, there's some intuitive thing that I don't actually understand about how airplanes fly. So I went on a rabbit hole and I figured out that actually there is a lot of physics. And I remember why I did not know that. This was me in every physics class. This man is actually awake. I was asleep for most of it. And I remember how bored I was, man, on physics classes. I think it was just too many equations, too much people speaking too slowly. Uh, but I've learned a lot of things post that, right? I've learned a lot of JavaScript. And I like JavaScript. JavaScript is awesome. You can talk to me about JavaScript any day and I'll never sleep. So with my newfound curiosity about airplanes and my existing love for JavaScript, I thought, why not marry these two and try and learn physics, but with JavaScript? And that is what this talk is about. I'm trying to get us to a point where we build an intuitive understanding of how an airplane flies, but using JavaScript so that we don't all fall asleep and die. The application that we're going to be building is an airplane simulator, not this one. This one's too awesome. Ours is going to look a lot more simple. It's going to be something like this. But the idea is that by the end of it, we all have a basic understanding of how an airplane actually lifts off the ground, how it stays in the air, and how it eventually lands. In order to go about this, we are unfortunately going to have to do a bit of maths. Don't worry, I'll try and make it as pictorial as possible. We're going to have to understand something about the forces that act on an airplane, whether it's on the ground, whether it's on top, or whether it's trying to land. We're going to have to learn about the canvas. We're not really going to learn about it, but we're going to use the canvas to draw the airplane on the browser, and then we're going to use a lot of JavaScript to animate it. Right. Without further ado, let's talk vectors. But if I'm going to talk about vectors or anything physics, I'm going to need a whiteboard. Now, this is my beautiful whiteboard tool. Imagine you're a guy and you live on a canvas and you have a superhero cape and you wanted to walk up just a certain direction, 4 meters straight up. You could just decide to walk straight up. Someone would ask you, what did you just do? And you could describe it like I'm telling you now, I walk straight up. Or you could draw an arrow. You could draw an arrow from the very point that you started and end it right where you ended and put an arrowhead like at your destination. That would be you creating a vector. A vector is any quantity that has both magnitude and direction whenever you're describing it. And vectors are going to be very important to how we sort of understand the physics behind what makes an airplane fly. Now, the reason vectors are important is that there's a lot of things that you can actually uh, explain using vectors. So for example, this specific vector is me describing a change in position. I went from point A and then I went to point B, right? Now that is called a position vector because one, it has a direction that the person went up, and then it also has a magnitude telling you that the person went 4 meters up. But there's a lot of other things that you can describe like that. So for example, if I was a real superhero and I decided to push an airplane with a specific force, I would be pushing it in a certain direction with a specific amount of force. So force is also a vector. If the airplane started to move, for example, and it traveled a specific distance in a particular direction, it would be moving at a specific velocity. So velocity is a vector. If I started to push really hard on the airplane and then it started to accelerate, it would be accelerating in a particular direction, and that acceleration would have a magnitude. So acceleration is also a vector. Now, things like force, acceleration, and velocity are going to be very important to how we think about what is happening to an airplane. One thing that's nice about vectors is that they also have another form. As much as you can describe the vector, with a magnitude and a direction, you can also describe it in terms of just two values: the amount of displacement on the x direction and the displacement on the y direction. And what makes that cool is that that's easier to code. So I'm just going to show you a snippet of code where we create a vector class which essentially just has two things. It has an X and a Y coordinate. And with that X and Y coordinate, we can always get back to our original magnitude and direction by using simple Pythagoras. So if you check here, if we get, say, x squared plus y squared, and then we square root that, we will get the length of the vector. So then we would have recovered our information. But what's nice about making it this way is that we can do a lot of cool maths. Well, we can make maths cool by making it easy. So say, for example, you wanted to make the vector longer. So I'm moving in a particular direction, but then I want to make it even longer by multiplying it by some value. With this new way of showing it, we can just multiply the x and the y value, and then the vector becomes longer. We can do something else with them. Say we have two vectors now, and you wanted to add them up. With with describing it with these two values, all you have to do is just add up the x values and then add up the y values. And that's essentially what we're going to be doing. We're going to be using forces here as the vectors, and then we're going to be adding them up somehow, and then making sure that moves our airplane. I'm going to show the airplane now, said airplane that we have built, and hope that we can, by the end of me flying this, have an intuitive understanding of why an airplane flies. Right? Now, what you see now is an airplane, just it's sitting stationary, nothing's happening to it. And the reason it's not moving is because there's actually no resultant force that is happening on it. Uh, Before we actually start to move it, let's have a basic understanding of all of the forces that actually act on the airplane as it's moving. Something Something that I probably should have figured out before I even got on my airplane journey is that the reason airplanes fly is because of the wings. Now, the wings are very special. They don't look special when you look at them, but they have this interesting shape called an airfoil, right? Now, whenever an object moves, so this is the very physics part of it, and I swear this is the most physics it's going to get. Whenever an object moves in a fluid, so like air is a fluid. I was very surprised to learn that, by the way. But yes, air is a fluid, and whenever an object moves in a fluid, it will it will exhibit some dynamic pressure. And that dynamic pressure, if you have pressure difference between the bottom and the top of the airfoil, it generates a net force called lift. So what you can see here is that you can see that if the aeroplane is moving forward in this velocity direction, there's a force called lift that is actually perpendicular to it. And then there's another force called drag. Now, the very smart people that built airplanes, they're like, oh, this lift force thing is cool. What if this lift force were to become high enough that it actually counteracts the gravity that is pulling us all down right now? And that is, in a nutshell, how airplanes fly. So this is a free body diagram. Uh, Free body diagram is this diagram that shows all the forces of all of the forces that are just acting on the airplane when it's either in flight or when stationary. So you can see here that the force that we are all familiar with is the weight. So it's the gravity pulling us down. But then if you start to add some thrust into it, so like you push it, or like the engine starts to like push it forward, then it will start to accelerate. But the moment it accelerates, it creates this lift force. And then the lift force also creates the drag force. As long as the lift force is higher than the gravity, the weight that's pulling it down, the airplane starts to fly. So when I learned this, I was mind blown. I was like, wait, it's not so intuitive, but then once you start to explain it with the physics like that, then it kind of like makes sense. So what we're going to do with our JavaScript is that we're going to try and model that entire situation. We're going to get it to a point where the airplane is stationary. We're going to apply some force to it. Then once we apply the force to it, it should accelerate enough that at some point our lift force should then be higher than the gravity, and then the airplane should fly. Some quick formulas that I Googled off the internet for all of these values is you have the first one, which is drag. So you can see that drag is dependent on the velocity, and the lift force is also dependent on the velocity. Drag is always opposite the direction of the velocity, and then the lift force is always perpendicular to it. So it's like pushing it down. So as long as you have your drag, which is like less than your thrust, and then you have a lift force now being higher than your weight, the airplane should fly. The weight is just mg, and then you have the engine. Okay, let's go back to our airplane. I built this airplane to have two controls because I'm not a pilot, but it was surprisingly still complicated to fly. The only controls that we have here are the thrust. So you can see that the thrust is 0 right now on all of the things that we're just logging out. So we see that the altitude is 0 because the airplane is on the floor. We have the gravity because we chose our weight to be like 3. So then we chose our gravity to be 10. What's nice about animations is that on the browser, you don't actually have to use realistic values. You just have to use the realistic formulas. So our gravity right now is 30 because our weight is 3, and then our gravity is 10. There's no lift force right now because the airplane is stationary. There's no thrust because we haven't applied it. There's no drag as well. And then the airplane has no velocity. What you'll notice now is that if I start pressing adding more thrust, as the thrust is increasing, the airplane starts to move. And you'll see that all of the vectors now are starting to increase. So as it's moving forward, because lift is a function of velocity, the lift is also increasing, the drag is also increasing, but the plane is still on the ground. No, that is why we have this runway on an actual airplane. So whenever you're on the runway, you're trying to get as much velocity as possible so that you eventually have enough drag. So then if I just increase the thrust here up until here, you will see that at some point, you'll see that the lift force is rapidly increasing. So it doesn't increase instantly, right? Because as you're putting in more thrust, the airplane has to generate momentum and everything. But eventually, once it gets to a high enough velocity, it will start to fly. Now, once the airplane starts to fly, if you just leave it like this, if you leave everything like this, it will climb up until heaven. We don't want that. We at this point we actually have to reduce the thrust. Once we start reducing the thrust, then gravity starts to take over, and then the airplane starts to level up. But then once it starts leveling up, you have to increase the thrust again in order to get it to the point where you want it to be. This is just two controls, and pilots are dealing with a lot more controls than this point. So I've earned a massive amount of respect for pilots just building this. So you can see now, the important bit at this point is that we're getting to a point where our forces are roughly equal to each other. So I'm just going to get to a point where the velocity in the y direction is basically zero. So at this point, we've gotten to the point where we are at cruising altitude. All of the forces on the airplane are actually balanced. And Newton's first law says that an object will remain stationary or continue to move at a constant velocity unless acted upon by net force. So at this very moment, there is no net force acting on the airplane. So it will continue moving at what is 60 pixels per second or so until it gets to a destination. So unless anything changes at this moment, this airplane will be at cruising altitude. This, I think, in aeroplane terms, is around the time where they tell us to like take off our seatbelts and we can start drinking alcohol. But driving airplanes is hard. As much as it would be nice to just sit back at this point and let everything happen, things change during the airplane. One thing that I didn't think about before I started doing this is that the weight of the airplane actually changes as the airplane is driving. The reason it changes is because it's burning up fuel. So then, say for example, as a pilot, you're at this moment, you're like, I'm at cruising altitude, and then all of a sudden you lose fuel, and then your mass decreases. But the moment the mass decreases, you can see that gravity starts to be less, right? And then the lift force starts to take over. The airplane immediately starts to climb. So at this point, you have to wake up and readjust the thrust if you want to get back to cruising altitude. You have to get back, readjust the thrust in such a way that you reduce the lift force to balance out the new gravitational force that you've created. So I'm just gonna try and be sorry, guys. I'm not a pilot. This does take a little bit of work to do. I'm gonna try and decrease it to the point where I get it back to cruising altitude again. If I can't, please forgive me. Cool. So at this point, we're sort of getting back to our cruising altitude, and we've been traveling far enough at this point that we are kind of approaching an airport. So we're about to get to a very interesting. Ooh. Okay, we're tired of cruising. We're about to get to a very interesting point where we're trying to land the airplane now. Now, landing is also just as hard as taking off. Ooh. So in order to land, you have to like reduce your thrust again, but now you have to control it in such a way that you reduce the thrust, but you don't want the airplane going straight down, right? So what you actually want is you want it to be reduced in such a way that the airplane gets to the ground, but at an angle that is roughly zero. And that is what pilots do when they try to land the airplane. That's why you can't actually just get down. It's going down too quickly. No. Okay. So we're going to try and be a very good pilot. This was my fear actually at Fly Surfing. I'm gonna try. No, I'm breaking. I'm breaking. I'm gonna try and break it. Oh. Okay. Landing an airplane is very hard, even on a computer. But that is the massive, complicated things that pilots have to deal with. They always have to be thinking about what is the drag today, what is the lift that I'm generating today, and it's not even that. This is like the least of the complication. The first dynamic value that I showed you was that the mass changes, but also the lift changes, the amount of lift force, and that we can see by going in here. So the way that we calculate lift is we use this value called a lift coefficient. So for every airplane and all of the wings that they create, they actually put it into something called a wind tunnel, and they test it out to test out what are the actual values of this. And what you can see here is that the lift force is a function of the angle of attack. So the angle of attack is how slanted the plane is when it's actually moving. So you can see that for this particular graph that I pulled up, at 0 degrees, the value is like 0.2. But then when it's slanted about 18 degrees, it gets to like a maximum value of 1.4. And if you slant it even more beyond that, you see the graph cuts off. That's where your life cuts off. At that point, the pilot actually loses control of the airplane, and there's no way to kind of recover it. So, but don't worry, that will never happen in real life because airplanes now have built-in control systems to actually prevent the pilot from making it climb too high to a point where they lose control. This is actually a cool picture I found of a wind tunnel where they're actually testing the wind thing, the airfoil, to check how much lift it can generate so that they can build an airplane around it. All right. At this moment, we have kind of gone through the taking off of the airplane. We've also gone through how it happens when the people get on cruise control. We've unfortunately not landed the airplane correctly, but I hope we are gaining a nice understanding, a nice intuitive understanding of how an airplane actually flies. So I'm gonna, for the last part, I'm just gonna go over the technical-ish details of it about how we actually get to this point where we can animate an airplane like this. So it all stems from Newton's second law of motion. So Newton's second law of motion in words states that whenever a net force acts on an object, the object will accelerate. Yeah, that's basically what it says. And in maths form, you can see that it's force is equals to mass and acceleration, but then you can rearrange it to find the acceleration from the force. So what we then do is that since we have a free body diagram, we kind of like know all of the forces that are acting on the airplane. We add them all up and then we get one resultant force. And it's easy to do that because we have vectors. So then we add up all our vectors and then we have a resultant force on the airplane. And then we use Newton's second law in this way. So now we have F and we know the mass of the airplane, then we calculate the acceleration. Once we have the acceleration, we can actually calculate the velocity from that acceleration. And then once we have the velocity, we can then calculate where the airplane should be having been moving at this acceleration at this velocity. I'm going to just say that again for clarity. Acceleration, the definition of it is the rate of change in velocity. So if I know my velocity, I have a velocity vector 1, and then I know that it changed by this much acceleration. If I just add those two vectors up, then I get my new velocity. But once I have my new velocity, I know that I had a specific position. My airplane was at a specific position. Velocity is the rate of change in position. So I have this vector that tells me where I was, and then I have this new vector telling me how my position changed. And then I add those two up, and then I get the new position. And then once we have that, then we draw it. Just draw it on the screen. And then if we do that on a loop over and over again, you can see that the animation just progresses in a way that looks realistic enough and allows us to gain understanding of how airplanes fly. In code, I'll just move on to this. This is just a simple React application. So I will move on to the crux of it, which is this one. So you can see that we first move the plane by having the initial position calculated and all of that, and then we first figure out if we've crashed or not, because there's no reason for us to move anything once we did. And then we get the force, we calculate the force of it, and then we have the net force. Then once we have the net force, we calculate the acceleration. Once we have the net acceleration, we get the velocity, and then we do it all over again. So we just basically running an animation loop that will update the acceleration and the velocities and everything over and over again. And what's interesting about this method is that you can model any kind of situation that has physics in it just with this. Because imagine you were modeling a submarine. The only things that would change is the forces that are acting on the object. So the only way to model anything in physics on the browser is just understand all of the forces that are acting on the object. And then once you have those, you're gonna calculate the net force. And then once you have the net force, you're gonna calculate the acceleration. Once you have the acceleration, update the velocity, and just keep looping it over and over and over again. The rest of the code is just to, draw the lift and the controls and all of that stuff. All right. That brings me to the end of my demo. Just to recap, I almost died sometime this year. Uh, I tried to learn how airplanes fly. And the reason airplanes fly is because of their wings. Their wings generate lift, which counteracts the gravitational force that pulls us all down. And JavaScript is fun. You can actually animate stuff with that. I had a lot of fun learning this. I thought about my days in high school and in varsity learning physics, and those were the days where I did not know JavaScript. And in those days, I didn't have any other route to take if I'm just not understanding the way that the teacher is teaching it to me. But over the years, I've gotten to a point where I learned about something called transfer learning, where you can take something that you know and kind of use that to learn something that you don't know. So at this point, I found my physics love. Yes, I do love physics now for some reason. I found that through JavaScript. So even as you're sitting here and you're thinking about there's something that you really want to learn, but for some reason it just does not compute whenever you are thinking about it, you can actually use transfer learning. You can think about some of the things that you already do know and try to incorporate those things into the new thing that you're actually trying to learn. If you're interested in JavaScript animations, as I've become these days, there's an excellent book. This book, it kind of like teaches you all of the physics and all of the things, but from the perspective of a developer. So it will always say, these are the formulas, but this is how you can code it. And then you can like be happy there. One quote from the book that I really loved is that the laws of physics are easy, but then the motions that they create are complicated. I chose to maneuver around it and say the laws of physics may be boring, but the simulations that you can produce are pretty fun. I hope we all learned something about airplanes today. I hope we're all not as confused about why this big bus actually flies up in the air. And I hope we found courage to learn new things by incorporating the things that we already know in that learning journey. Thank you very much. Any questions?
Hello. Um, this got me thinking about how planes make a U-turn in a way. Because, when you're in a car, you get the steering wheel and the wheels actually turn, right? Do you know how that would work then with an airplane? Question number 2, do you use the same rules to possibly create a game out of this? Does that make sense?
Yes. Okay. So your first question, I did not model any of that because this was entirely in 2D, but the lift force, there's not just one lift force that actually happens on an airplane. There's multiple. So if you look at it has like multiple wings and then it has a tail. So then the way that it turns is that it just changes the amount of lift force on different parts of the airplane, which then either makes it roll or either makes it turn. So, for example, if you think of the wings like this, if I have more force pulling me like this, and then I have less force, I have more force pushing me down here and more force pulling me up here, I would turn like this. And that is essentially how an airplane turns. They just have the different parts of the airplane that maneuver all of the lift forces, and then they can perform all of the maneuvers like that. To your second point, creating a game, definitely. So you could create a game if, like, you could turn this into a game. You can program rules onto it. You can program points and stuff like that. So, for example, the crash landing that you saw, that was just a rule that I programmed in there to say that if the airplane has reached the ground at this velocity, or in these kind of conditions, then the airplane has crashed. So then you create different scenarios around that. Cool. Anyone else?
Hello.
Hello.
Anyway, so my question is you mentioned transfer learning, right? So, hypothetically speaking, if I'm not a dev, so JavaScript is not my fun place, but I wanted to learn maybe physics, what alternatives can I do? Or do I have to learn how to code before I can learn transfer learning?
Oh, it's a good question.
You are.
Uh, well, I went to JavaScript because I'm JavaScript guy. That's what I already know. But there's a lot of other things that you might be interested in. That, for example, that would make your learning a lot more interesting. So, say for example, you love making videos, right? Or watching YouTube videos. So you could use your love for making videos and do practical things with the physics and videotape yourself doing them by learning while learning the physics. So you could look at like what your passion is currently and just think about how you could incorporate that specific passion to learning something new. I hope that answers your question. Anyone else? All right. I think that brings us to the end of our talk. Thank you very much, everyone.
Hey, I got a question. Everybody sit down. Calm yourselves. um, what are you building next?
What I'm building next? I actually don't know. That was what I was thinking about just this morning.
Okay, something with joints that move.
So I'm
hard.
thinking I was very inspired this morning by the Raspberry Pi stuff. One of the other things that I was terrible at school was building anything that is not just software. As long as it's software, I can build it. But if it starts to have to do with hardware and things actually have to work, I'm terrible at that. So I might give that a crack again because it looked pretty fun.
Very cool.
Yeah. Right. Thank you.